Okay, so this is for section 4.3, which is all about converses. Converses are flipping a statement around. So you can see this first statement. If a quadrilateral is a parallelogram, then it has opposite sides that are parallel is what that should say. The converse of that would be, if a quadrilateral has parallel opposite sides, then it's a parallelogram. So if I flip the statements I did yesterday I knew I had parallelograms, so I knew facts about this. This time, I'm going to use those facts to prove something is a parallelogram. So it works for all of our statements. So if a parallelogram, I knew my opposite sides are congruent. But if I know the opposite sides are congruent, then the shape is a parallelogram. So I can flip it. Again, if a parallelogram, the opposite angles are congruent. Well, if the opposite angles are congruent, I know that shape is a parallelogram. It's a way I can prove it. We like to prove things in math, not take guesses. If a shape is a parallelogram, I know those consecutive, the angles next to each other, are supplementary. Well, if the consecutive angles are supplementary, the shape has to be a parallelogram. And finally, if a parallelogram, then the diagonals bisect each other. If the diagonals bisect each other, then the shape is a parallelogram. So what we're trying to do here is show how to prove a quadrilateral is a parallelogram. How would I do that? The first thing I could do, I know something is a parallelogram if opposite sides are parallel, because parallel is just in the name here, right? So if those opposite sides are parallel, then we have a parallelogram. I also know if the opposite sides are congruent. Both pairs, it's a parallelogram. If I can show opposite angles are congruent, then it is in fact a parallelogram, both pairs. If I can show all pairs of consecutive angles are supplementary, remember that means we're adding up to 180, then I know something is in fact a parallelogram. If the diagonals bisect each other, something is a parallelogram. And another fun one is if one pair of opposite sides are congruent and parallel. So I'd only need to know about one side. If I knew information, it would be enough to say that I have a parallelogram. Okay? So what might questions look like with this? It says use the converse statement above to complete this list. And I'm just going to step it out without their guidance. It says follow these steps to find the value of x that makes ABCD a parallelogram. So what value would x have to be in this statement for this to be a parallelogram? Well, what I'm given here are A and D, which are consecutive angles, right? So my rule about consecutive angles is these two should add up to 180. So if I want x to be something that makes this a parallelogram, I need 120 plus 3x equal to 180. And now I'm going to solve this two-step equation. So subtract. I get 3x equal to 60, and I'm going to divide by 3. So x equals 20. Thus, I know if x is 20, I can say this is a parallelogram. So that's what we're trying to do. It's very similar to what we did yesterday, just kind of a different framework.